Hi everybody, welcome to today's video where we are going to learn about quadratic sequences, or more specifically, how to find the nth term of a quadratic sequence. Before we begin, make sure you watch this video on identifying sequences so you know how to spot a quadratic sequence when you see one. So let's recap. What is a quadratic sequence? A quadratic sequence is when the difference of the difference is the same. This might sound confusing, but I promise it's not that hard. If we have this sequence 1, 4, 9, 16, 25, 36 and 49, we can see that there's not a constant rule. As you go up, it's plus 3, plus 5, plus 7, 9, 11 and 13. But however, if we look a bit closer, the difference of the difference is always plus 2. You have to add 2 to get from 3 to 5, from 5 to 7, from 7 to 9, 9 to 11 and 11 to 13. This is a quadratic sequence. If you really want to know, this is the n squared quadratic sequence. So let's begin on how to find the nth term of a quadratic sequence. I've written the method up at the top because there's quite a lot of steps for you to remember. So we have 8, 20, 38, 62 and 92. So first we've written out the sequence, now we need to find the difference. So we're going up by 12, 18, 24, 30. The difference of the difference here is plus 6. We next have to divide the difference of the difference by 2. So 6 divided by 2 is 3. Now we have to calculate the 3n squared sequence, because this is half of 6. The 3n squared sequence sounds hard, but it's not that hard. It's basically 1 squared times 3, 2 squared times 3, 3 squared times 3, 4 squared times 3, 5 squared times 3, etc. And if we were to do that, we'd get 3, 12, 27, 48 and 75. Now we need to compare our original sequence of 8, 20, 38, 62 and 92 to this sequence. So if we write it underneath, we can see that you have to add 5, 8, 11, 14 and 17 each time to get from the 3n squared sequence to our sequence that we're trying to find the nth term of. These numbers that are the comparison, 5, 8, 11, 14 and 17, they form a sequence in themselves. And this is the 3n plus 2 sequence. This is the arithmetic sequence, so make sure you've watched that video if you don't know what that is. Then we can get these two components that we have found, 3n squared plus 3n plus 2, and put them together and we get the 3n squared plus 3n plus 2. This is the quadratic sequence for 8, 20, 38, 62 and 92. Example 2. Try this one out yourself. So let's go through it now. We have 9, 19, 33, 51 and 73. If we find the difference between each of these, we get 10, 14, 18 and 22. The difference of the difference is 4. Can you remember the next step? The next step is to divide this by 2. So 4 divided by 2 is 2. So there we have to find the 2n squared sequence. So 1 squared times 2, 2 squared times 2, 3 squared times 2, 4 squared times 2, and so on. We get 2, 8, 18, 32, and 50. Now we have to compare this to our original sequence. 9, 19, 33, 51, and 73. If you find the difference here, we get add 7, add 11, add 15, 19, 23. And if you remember from before, this forms a sequence in itself. This is the 4n plus 3 arithmetic sequence. So now we get the two components we found, the 2n squared and the 4n plus 3, and we can combine these together and we get 2n squared plus 4n plus 3. This is the nth term of the quadratic sequence 9, 19, 33, 51 and 73. So you can pause the video here and try out these questions. If you really feel like a challenge, there's a negative quadratic sequence down below, and you can try that one if you have enough time. Now you can mark your work. Let me know how you did in the comment section below. Example 3. Work out the nth term of this sequence. 10, 7, minus 2, minus 17 and minus 38. You might notice something different about this sequence. This sequence is going down. To get to each term you have to minus a value. So minus 3, minus 9, minus 15 and minus 21. Nevertheless, it is still a quadratic sequence because the difference of the difference is always minus 6. So you have to be careful with your negatives, as you always have to be in algebra. So you do minus 6 divided by 2 this time, and that is minus 3. Don't convert that into a positive 3. So you have to find the minus 3n squared sequence. So this is basically the 3n squared sequence, but everything has a minus in front of it. And we have to compare this to 10, 7, minus 2, minus 17, and 38. So if we find the comparison, you have to add 13, 19, 25, 31, and 37. This is an arithmetic sequence of 6n plus 7. So therefore, we get the two components that we had, and we do minus 3n squared plus 6n plus 7. Don't forget your minuses. You need to get them the right way round. This is the nth term for the sequence 10, 7, minus 2, minus 17, and minus 38. Pause the video here and try this one out before I explain it. So this is another negative quadratic sequence, and as you can see, the difference of the difference here is minus 10 each time. Then we do minus 10 divided by 2 to get minus 5, and we need to work out the minus 5n squared sequence. The sequence for minus 5n squared is 1 squared times minus 5, 2 squared times minus 5, 3 squared times minus 5, and so on. We get minus 5, minus 20, minus 45, minus 18, minus 125. Comparing that to the original sequence we have, we can find to get from each term of the minus 5n squared sequence to the original sequence, you have to minus 7, minus 9, minus 11, minus 13, and minus 15. So this one is a bit more tricky than the other ones that we've tried. However, minus 7, minus 9, minus 11, minus 13, minus 15, this forms the arithmetic sequence minus 2 and minus 5. We get our components and we make sure we're aware of the negatives, and we get the answer minus 5n squared minus 2n minus 5. So here are a bunch of questions for you to try, and they get increasingly difficult as you get to the red section, but have a go at all of them, and the answers will be in the comment section below. I hope you enjoyed today's video and you understood it really well. Make sure you like and subscribe, and thank you for watching. See you next time. Bye!